Today we are covering section 2.7 from our BJU Press geometry textbook. We're going to discuss polyhedra. Our objectives today are to define what polyhedra are and any other related definitions. We're also going to identify names of simple polyhedra, and we're going to classify polyhedra as either regular or non-regular. So let's take a look at a basic definition of what polyhedra are. We've already talked about prisms and pyramids, and if we think about prisms and pyramids, they differ from spheres because they have flat faces, whereas a sphere doesn't have any flat faces. So whenever we have these flat faces, we call those surfaces polyhedra. So a polyhedra is a closed surface made up of polygons, regions. A face of a polyhedron is one of those regions that make up the surface of the polyhedron. The polyhedra that we study in this course are simple, okay? So if a polyhedron is not simple, it's going to have a hole in it. But anything that we're studying right now is all simple. So we name polyhedra according to how many faces they have. If it has 4 faces, it's a tetrahedron. 5 will be a pentahedron. 6 will be a hexahedron. 7 is a heptahedron. 8 is an octahedron. 10 is a decahedron. 12 is a dodecahedron. And then we even have something that is a 20-faced polyhedra, and that is an icosahedron. So let's get some practice in. Let's classify the polyhedron based on the number of faces. So in this figure, you can see that there are 4 sides. Here's 1 face, 2 faces, 3 faces, and then 4 faces. So 4 faces would be a tetrahedron. This one has 8 faces. Here's 1, 2, 3, 4, 5, 6, 7, 8. So we call that an octahedron. The next one has 6 faces. So we say that's a hexahedron. This one is a little bit more difficult to count, so I'm going to show you a trick. This makes up a cone because everything is going up to this point, okay? Our base of this cone is a pentagon, which means it has 5 sides. Notice that each side makes up a triangle, so we know that we have 5 triangles, and then we have the base. So that means we have 6 total sides, which makes this a hexahedron. This is what we call, this is the 20-sided polyhedra. It is the icosahedron. So this one right here is going to be an octahedron. If you notice that the base is a hexagon, so each side of the hexagon makes a rectangle. So we know that we have 6 rectangles, but then we also have 2 bases because it is a prism. So 6 plus 2 is 8, which makes it an octahedron. This is also an octahedron. This one, if you notice, it is a heptagon because there are 7 sides. So that means we have 7 triangles. But with the base, or with the bottom, that's 8 faces. So that means that we have an octahedron. So a regular polyhedron is a convex polyhedron having 2 properties. The first property is that all the faces are identical. They have to be the same size and shape. The second property is that there's the same number of edges meet at each vertex. There are only 5 possible regular polyhedron. There's a regular tetrahedron, which is 4 faces, a regular hexahedron, which is 6, a regular octahedron, which is 8, a regular dodecahedron, which is 12, and of course the regular icosahedron, which is the 20-sided. So here's an example of a regular hexahedron. You might recognize this as a cube. The intersection of adjacent faces are the edges of the polyhedron. So edges are going to be like the segments. The endpoints of the edges are called the vertices. So these are the points of the polyhedron. That's all there is for this lesson. Go ahead and try the problems.